All right, so 12.7 is about systems of inequalities, both linear and nonlinear mixed in here. So we'll start with a linear one, something we've done before, just to jog our memories as to what we're even looking for when we look at a system of inequalities. All right, so two inequalities. We're going to solve that system. Well, the problem with solving a system of inequalities compared to a system of equations is we don't have the three scenarios anymore because they're inequalities. The three scenarios with equations was it's one solution, infinitely many solutions, or no solutions. Well, we only have, two scenarios here. It's either a whole bunch of solutions or none. There's no one solution to a system of inequalities because we're looking for overlap of the graphs, like the shading part of that. So what we're going to do is we're going to graph both of these on the same coordinate plane and shade them correctly, and we should see some overlap happening. So that means I need to get them both in what form? Yeah, y equals y by itself, slope-intercept form is the key. So this one easily done. 3x minus 7. This one would be negative y greater than or equal to negative 2x minus 4. But then I divide by negative 1 to make that 2x plus 4. But when I divide by negative with inequalities, what has to happen? Flip the symbol to get y by itself. Okay? Anytime I divide by a negative, I'm going to have to flip that symbol around to get y by itself. Okay, so very simple start to the lesson here. Let's graph those on the same coordinate plane. So I know I've got to go have a y-intercept of negative 7 and one of positive 4. So trying to make sure I got room for that. I'm going to draw my coordinate plane. So the first one, I'll graph that in blue. Y-intercept of negative 7. Slope of 3 over 1. What kind of line should I draw? Don't say straight. Dotted, yeah, jagged. I've never heard it called that, but that's exactly right. The dotted is the jagged. We'll call it jagged from now on. Jagged line. Dotted line. Okay. And then the second one, we'll graph it in red. Well, wait, but are we done with the blue one? No, we got to shade it. So we got to decide which way to shade that. How do you decide which way to shade that? And decide what? If it's true or not. If it's true, where do we shade? Toward that point. And if it's false, we shade away from that point. What point do we want to use if at all possible? The origin, 0, 0. So if I plug 0 into this inequality, 0 greater than negative 7. True? No. Yeah, so I'm going to shade the left side of that, I guess, would be the best way to describe that. Using the yellow highlighter. Just lightly shade that with your pencil if you're using. Okay. All right, so we got all that side done. So that inequality is finished. Let's graph the second one. It has a y-intercept of 4, slope of 2, and I could go up 2 over 1. I could go down 2, left 1. Dotted or solid? Why is it solid this time? This has got equal to mark. And then same way about deciding which way to shade. 0 less than 4 is less than 4. So I'm going to shade what would be maybe the right side or the bottom side of that line. So that would mean this side. And then the green portion is the solution area. The overlap, the darker portion of your graph, where the two regions meet. And this is your solution.
So the dotted line is everything to the left.
Mm-hmm. Yeah, and any ordered pair in this green area is a solution to that system. So we really have infinite number of solutions to an inequality every time. If there are any solutions, there's an infinite number of solutions to that. Okay, so nice, easy, linear one to start off with. Stuff you did in Algebra 1, a little bit in Algebra 2. Let's do a non-linear one. I like these better. They're fun. More fun. Funner is not a word, sorry. So we have y is greater than or equal to x squared minus 4. So what is that? Parabola. So it's nonlinear. And then we have x plus y is less than or equal to. So that's a straight line, right? So we've got a mixed one here that's got linear and nonlinear in it. This one would be really easy to get y by itself. Just subtract x. I know I've got to get y by itself. I'm going to graph these things anyway. Unless it's something a little bit more special. I'll just draw a generic coordinate plane. All right, so graphing that parabola, how do we do that? Okay, the vertex would be 0, negative 4. This b is 0, negative b over 2a. Get you that. You could just plug in some x values if you want to. That's one way of doing that. You could type in y equals x squared minus 4 on your calculator and get you the picture of what's going on. Just so you know, just a lot of options there as far as getting the idea where you're going. If I plug in 1 squared is 1 minus 4 is negative 3. If I plug in 2 squared is 4, that's 0. And then I know it's symmetric. So I know, and is that a dotted or a solid line? Solid because it's equal to, so get that parabola shape going there. Shading, there's not a left side, right side, there's an inside, outside on the parabola. I'm going to shade either the inside of it or the outside of it. So let me check the origin if I can. And I can because it doesn't go through it. So 0 greater than negative 4. Yeah, it is. So I'm going to shade the inside of this parabola. So everything inside there, including the solid red line, are the solutions to that inequality. The second one is a line. So I would go to positive 2 on the y-axis, and then a slope of negative 1. It's a solid line as well because it has the equal to mark. I'll check the origin, 0 less than 2. That is definitely true. So I would shade below that line for the solution area. Is this overlap in the middle right here? I think that's a little bit more fun than the new ones. What are you confused about? Graph the equation, shade the direction that is true. If you plug in an ordered pair, that tells you, and then you test it. We're plugging in 0, 0. For this one, 0 greater than or equal to 0 squared minus 4. 0 greater than, that's true. That's my inside, we shaded the inside of the parabola. This one, plug a 0 in, 0 less than or equal to 0 plus 2. So 0 less than 2, yes. So that's why we shaded towards 0, 0 on the other one. All right. One more for this section. X squared plus y squared is less than 4. And y is greater than or equal to x squared plus 1. What's the first one? Circle. Y'all remember that from geometry, hopefully. What's the radius of that circle? 2, square root of 4. Whatever the number is over there, take the square root of it. So the radius is 2. What's the center of that circle? The origin, yeah, 0, 0. If there's numbers plus or minus to the x's inside the parentheses or the y's, that shifts it left, right, up, left or right. If there's nothing there, it's centered at the origin. So this one, centered at the origin with a radius of 2, and it's a dotted line. So it's a circle. It does that. That's a horrible circle. Let's try again. It's not bad. It's not great, but it's not bad. And then shading. Again, we can still test 0, 0. Is 0 plus 0 less than 4? Yes, so that means we're going to shade where on that circle? Inside of that circle. All right. And then the second one is what shape? Parabola shaped. With a vertex where? What one? 0, 1. And then pointing up. So plug in a 1, 1 plus 1, 2, 2, 5. And then solid line. And then shading, 0, 0 would be on the outside of it. So I'm going to check 0 is greater than or equal to 0 plus 1. Is 0 bigger than 1? No. So that's on the outside. So that means I'm going to shade where? On the inside of the parabola, yeah. So my overlap is going to be that small little bit there toward the top of the circle. This is not bad. This is really not bad at all. This, yeah, really it is. There's no harder part. A lot of, yeah, it just mixes in those non-linear pieces that you didn't do in Algebra 1 or 2. Chapter 12 test is Friday. For chapter 12, Wednesday. So you'll have Thursdays. Some of you have tests Thursday, so that's why the test is not Thursday. EOC, I have to look at the schedule and see which one's which, because the order is not the same as it's been in the past year. Usually math's the first one, but it's not first this year. No, just kidding. I'd rather be first. All right, so 12-8. All right, so linear programming. This week, I could make this very difficult, but I'm not going to. Linear programming is taking a set of constraints. Constraints in math just means some rules. And if we're talking about constraints in our context, constraints, we'll just do an example here, and I'm going to swap to graph paper because I forget that it doesn't do it automatically. Because I don't want to do it automatically. All right, so constraints. That's what they're called. So if they say, what are the constraints? X is greater than or equal to 0. Y is greater than or equal to 0. X plus Y is less than or equal to 25. X is greater than or equal to 15. And then Y is less than or equal to 5. All right, so you get what's called an objective function or objective equation. And the variables, like what it's equal to, this is I. It really doesn't matter what that letter is. They may have Z equals this, but the problem will have X and Y in it. Okay. Now, what we have to do is graph these constraints on a coordinate plane. All of them. So on one coordinate plane. So it's a system of inequalities, right? Just like what we just did. They're all linear in this case. They will be in this section for the most part.
Like, so there's going to be a different set of constraints for each question.
Mm-hmm. Yeah, there'll be a different set of constraints and maybe a different objective function for each equation. How about that? So
I just thought that was like a standard.
No, these two are usually on there on every one of them, just because where these linear programming problems come from are real world problems, like business application of inequalities. And if you're dealing with business, and you're building something, like you're making a product, you don't worry about, your negative part of that product. No negative parts are made here, or no negative products are made. That you're counting towards your profit or your revenue or whatever or no negative sales, I guess would be a better way to say that. Because if it's sold, you made some sort of money off of it. So let's graph that on a coordinate plane. Now, the thing we're going to run into here is the fact that we got one of these that goes up to 25 and one goes down to 15 and 5. So what would be a good scale to go by here? By fives. That'd be a great way to do things. So that's what we're going to do. And I don't need much in the way of negative part of the coordinate plane because I don't have any negative going on. So when I graph those inequalities, x is greater than or equal to 0 is this vertical line right on top of the y-axis, and its shading goes this direction because it's greater than 0, right? So that shading, I'm not going to shade them individually because then it gets to be too much shading going on, and I can't shade really lightly. You guys can shade as lightly as you can on with your pencil if you want to. I'm just going to use arrows to indicate which direction we're shading. Okay. The y is greater than or equal to 0. Well, that's a horizontal line because it's y equals a number right on top of the x-axis, and its shading would go up because it's greater than. Okay. And then I have the x plus y is less than or equal to 25. So if I'm going to go by fives on that, 25 would be, the y-intercept of 25 would be 1, 2, 3, 4, 5 units up. So that'd be right there. And then its slope is -1, so that'd be down 5 over 5. Get you there. You could do that direction, and then you've got this. And as far as determining which direction to shade that, you do the same thing. You say, okay, 0, 0. 0 plus 0 is less than 25. Is that true? Yeah, so that means I would shade this direction on that red one. And then the x is greater than or equal to 15. 15 would be, where at? The third mark, right? Third mark this way. Get you there. X in the number, vertical line. Greater than is going to shade to the right. So right now, if we didn't have this last one to do, our solution area would be this little triangle here. We got one more to go here. This y is less than or equal to 5. But this triangle would be where it's at if we stopped here. Now y is less than or equal to 5, so that's going to be this line right here. It's It's less than, so shading is going down. The solution area is this little trapezoid-like shape right here. All right. That solution area is not necessarily what I'm after. What I'm after are the corners of that solution area. So what are the ordered pairs that are the corners of that? So this one's really nice because it made the numbers work out really good. A lot of them in this section do. Either that or you already have the picture drawn for you, which is nice when they do that. So here is 15, 0. So, this would be 15, 0. There's 15, 5 right there. That point right there would be 25, and there's 25, 0. There are 1, 2, 3, 4 corners for that. The corners of that are what we're going to plug into the objective equation as x and y. And we're looking for a maximum or a minimum. They're going to tell you, find the maximum whatever of this. And those corners are the ordered pairs that you're using. Okay. So your corners or vertices, if we were in a geometry class, 15, 0, 15, 5, 25, and 25, 0. And then you want to maximize, and we're going to do both on this one, minimize, so we don't have to do 2 examples. Same work. So what we're going to do is take that objective function, I equals 0.02x plus 0.03y, and we're going to plug in that ordered pair, x and y. And get its value. That one, 0.02 times 15, be 0.3. And then this one, plug it in. It'd be 0.03, and then 0.15, be 0.45. This one, plug in 20 for x, 5 for y, 0.4 plus 0.15 is 0.55. And then this one, plug in 25 for x and 0 for y. .54 or 50. Okay. Maximum's the biggest answer. Here's our max, and our min would be here. Out of that. The location of that would be at this place, and this place. The ordered pair is the location. The value is the max or the min part. And not much more difficult than that. When you look at that section, When you're looking at that section, like they give you the picture on part of that. I'm going to give you the picture on part of the problems from this. And then on the other part, they give you the objective equation and then the constraints and ask you to draw the picture on it. So it's not, it's exactly that. I'm not to make it more difficult, we could do the word problems, and I'm not doing those to you. Okay. Save you a little headache there. All right, so Section 12.7, page 921, 11 through 51. Skip over 17, 21, 39, and 41. Section 12.8, page 927, 3 through 17. So there you're drawing the graph. We're going to match up the graphs on the quiz. You'll be matching up the graph that matches the system of inequalities. This, you're going to have the picture and have to maximize or minimize it, or I'm going to ask you to draw the picture on your own and maximize or minimize it. Pretty easy on the end of here. Okay. Workday tomorrow, quiz Wednesday. You'll get whatever time is left on Wednesday and Thursday to work on the review for Chapter 12 test, which will be Friday. Your final exam is still next Wednesday. And you'll get the practice final for that this week as well. Okay. All right. Okay. So then you will need to find time to get that in. Yeah.